All right, strap yourselves in because today we're going deep, deep into the world of antimatter.
Antimatter.
You know, it's one of those things that sounds like it's straight out of science fiction,
It really does.
but it's actually real. And we've got a whole bunch of research papers and articles here.
Yeah,
And we're going to break them down and pull out all the coolest,
absolutely.
most important stuff you need to know about antimatter.
And I think what's so interesting about this is that there is so much mystery surrounding antimatter.
Yeah,
I mean, this is something that should exist in equal amounts to the matter we see around us,
right.
but it's seemingly vanished after the Big Bang.
Yeah, it's like the universe is playing hide and seek with us.
Totally.
And we're just starting to get a little peek.
Yeah.
So I guess to kick things off, let's just define what we're talking about.
Oh.
What exactly is antimatter?
So at its core, antimatter is composed of antiparticles,
Okay.
which are basically mirror images of the particles that make up the familiar matter we see every day. So imagine an electron, but with a positive charge instead of a negative charge.
Okay.
That's a positron,
Right.
the antiparticle of an electron.
Okay.
And these antiparticles have the same mass as their matter counterparts, but their charges and other quantum properties
Right.
are reversed.
So it's like the universe has like a negative setting for everything.
Yeah.
Like a photo editor or something.
That's a great analogy.
Yeah.
And just like combining a photo and its negative image might lead to some interesting effects.
Yeah.
When matter and antimatter meet, things get really intense.
That's right. And I've heard about this whole like annihilation thing.
Yeah.
Is it as dramatic as it sounds?
It's pretty mind-blowing.
Yeah.
When matter and antimatter particles collide, they completely annihilate each other,
Whoa.
converting their entire mass into pure energy.
No, they just disappear in a burst of energy?
Pretty much.
Where does all that energy go?
So it's primarily released as gamma rays, which are incredibly high-energy photons.
Gamma rays, wait a minute.
Yeah.
Isn't that what they use in those PET scans that you hear about in hospitals?
You got it. Positron emission tomography, or PT scans, utilize positrons. And when injected into the body, these positrons encounter electrons in your tissues.
Right.
And boom, annihilation occurs,
Okay.
releasing gamma rays that doctors can then use to create these detailed images of your internal organs and tissues.
So this seemingly like exotic concept of antimatter
Yeah,
is already being used in medicine.
that's right.
That's wild. But here's the thing that's always bugged me.
Okay.
If matter and antimatter were created in equal amounts during the Big Bang,
Right.
shouldn't we see equal amounts of both in the universe today?
And that is one of the biggest unsolved mysteries in physics,
Really?
the matter-antimatter asymmetry problem.
Okay.
According to our current understanding of the Big Bang,
Yeah.
there should be as much antimatter as matter.
Right.
Yet when we look out into the cosmos, we see a universe dominated by matter.
So where did all the antimatter go?
That's the million-dollar question.
That's a real head scratcher. So how are scientists even trying to unravel this mystery?
Well, they're doing some incredible work at places like CERN,
Okay.
the European Organization for Nuclear Research.
Right.
One recent breakthrough was actually confirming a fundamental prediction about antimatter.
Oh.
It responds to gravity just like regular matter.
So antimatter falls down just like an apple falling from a tree.
Exactly.
That seems pretty basic, I feel like, but I bet that's a huge deal for scientists.
It is. It is.
Yeah.
For decades, it was theoretical, but now we finally observed it.
Wow.
And this seemingly simple behavior confirms a lot about our understanding of gravity and antimatter.
Okay.
But it also makes the mystery of the missing antimatter even more perplexing.
Right, because if it behaves like matter gravitationally,
Exactly.
what caused this cosmic imbalance?
It deepens the mystery.
It does. But, okay, here's another question I have.
Okay.
If antimatter is so rare
Yeah.
and annihilates on contact with matter, how do scientists even study it?
It's incredibly challenging. But scientists are resourceful.
They are.
At CERN, they've developed techniques to create and trap antimatter particles
Okay.
using sophisticated magnetic fields.
Oh, wow.
These traps suspend the antimatter in a vacuum, preventing it from coming into contact with matter and annihilating.
So it's like building a force field to contain this incredibly volatile substance.
That's a great way to put it.
That's incredible.
It's a testament to human ingenuity.
Yeah.
And these efforts are already leading to some really exciting discoveries.
All right, I'm hooked. Tell me more about these discoveries.
Well, let's dive into that right after a short break.
All right, we'll be right back. Okay, so what kind of discoveries are we talking about here?
Well,
What are scientists learning from all this antimatter research?
so one of the most exciting areas of research is antimatter's potential applications.
Okay.
I mean, we've already talked about its use in PIT scans.
Right.
But researchers are also investigating its potential in cancer treatment with a technique called antiproton therapy.
Antiproton therapy.
Yeah,
That sounds pretty intense.
it is. It's a highly targeted approach.
Right.
Beams of antiprotons, which are the antimatter counterparts of proton,
Right.
are directed at tumors.
Okay.
And when these antiprotons collide with the atoms in cancer cells, they annihilate,
Oh, wow.
releasing a burst of energy that damages the DNA of the cancer cells.
So it's like a super precise form of radiation therapy.
Exactly.
Oh.
And what's particularly promising about antiproton therapy is that the energy release is highly localized,
Okay.
which minimizes damage to the surrounding healthy tissue.
Wow.
So this could be a game changer for treating cancers
Yeah.
located deep within the body or close to vital organs.
That's amazing. It just makes you wonder what other medical marvels antimatter might unlock in the future.
The possibilities are really mind-boggling.
Yeah.
Imagine even more advanced imaging techniques allowing doctors to diagnose diseases
Right.
at earlier stages with incredible precision.
Okay, so antimatter has the potential to revolutionize medicine.
Mm-hmm.
But what about other applications? I
Mhm.
mean, earlier we briefly touched upon the idea of antimatter spaceships.
Right.
Is that really within the realm of possibility?
So harnessing antimatter for energy or propulsion,
Yeah.
it definitely captures the imagination.
Because.
But the reality is we're still a long way off from antimatter-powered spaceships.
Okay.
The challenges are immense.
All right, like what?
Well, first off, producing antimatter
Yeah.
requires an enormous amount of energy.
So we're basically trying to reverse the process of annihilation,
Essentially, yeah.
which is no small feat.
It's not easy.
So even creating just a tiny amount of antimatter takes a ton of energy and effort.
Exactly. Facilities like CERN,
Yeah.
they produce minuscule amounts of antimatter.
Okay.
We're talking nanograms,
Nanogram.
which is 1/1000th of a gram.
Wow.
And then there's the issue of storage.
Right, because you can't just keep antimatter in a regular container
Yep.
because it'll annihilate on contact with regular matter.
Exactly.
So what do?
Well, scientists use those sophisticated magnetic traps that we talked about
Right.
to suspend antimatter particles in a vacuum.
Okay.
And this prevents them from coming into contact with the walls of the container and annihilating.
So they've basically created a real-life force field.
In essence, yes.
Huh.
But these magnetic traps are incredibly complex and energy intensive to operate.
So it sounds like we have a long way to go before antimatter becomes like a practical
Yeah,
source of energy or propulsion.
it does.
Okay.
And let's not forget the efficiency aspect. I mean,
Mm.
currently, the energy required to produce antimatter
Yeah.
far exceeds the energy that could be released from it.
Oh.
We're talking about a net energy loss,
Huh.
making it impractical as an energy source at this point.
So while antimatter spaceships might be a ways off, I guess, the research being done today
Ah.
is still paving the way for some incredible breakthroughs.
It really is.
It's like we're opening up this whole new frontier of scientific exploration.
Absolutely. And perhaps the most profound impact of antimatter research lies in its ability to challenge our fundamental understanding of the universe.
Okay.
You know, remember that matter-antimatter asymmetry problem we talked about earlier?
Right. Where did all the antimatter go?
Exactly. So scientists at CERN are actually conducting experiments
Okay.
that could revolutionize our understanding of why the universe is the way it is.
What kind of experiments are they doing?
Well, they're looking for any subtle differences in the way matter and antimatter behave.
Okay.
Could there be tiny variations in their properties that we haven't detected yet? Are there differences in their magnetic moments, for example?
Right.
Or their response to gravity beyond what we've already observed?
And if they find those differences.
It could rewrite the textbooks.
Wow.
It could point to new physics
Yeah.
beyond our current understanding, offering clues as to why the universe evolved with this matter-antimatter imbalance.
So why is our universe made mostly of matter?
That's the big question.
It's incredible to think that something so seemingly exotic as antimatter
I know, right?
could hold the key to unlocking some of the universe's deepest secrets.
It really is a testament to the power of scientific inquiry. The quest to understand antimatter is leading us down a path of discovery
Yeah.
with profound implications for physics, cosmology,
Right.
and our place in the universe.
This has been an incredible journey so far, from its medical applications
Yeah,
to its potential to reshape our understanding of the universe.
absolutely.
Antimatter is clearly more than just a science fiction concept.
It's much more than that.
It's a fundamental piece of the cosmic puzzle.
Definitely.
But I feel like we've just scratched the surface here.
Yeah.
What other mind-blowing aspects of antimatter are out there waiting to be explored?
Well, there's one question
Okay.
that always sparks fascinating discussions.
Okay.
If antimatter is real,
Yeah.
could there be entire anti-universes out there
Anti-universes.
made entirely of antimatter?
Whoa.
It's a thought-provoking concept. So if antimatter is real, could there be entire anti-universes out there made entirely of antimatter?
Yeah, anti-universes.
I mean, it's a thought-provoking concept to consider.
it's like something straight out of a mind-bending sci-fi movie, right?
Totally.
Like, are we talking about anti-stars, anti-planets, maybe even anti-life out there?
Yeah, if we take the idea of antimatter seriously and everything we've learned so far
Right.
suggests we should,
Mm-hmm.
then
Yeah.
the possibility of anti-universes
Yeah.
becomes a question we can't ignore.
So theoretically, there could be like a mirror universe out there
Yeah.
made entirely of antimatter where everything's just the opposite of what we know.
Right.
Has there ever been any evidence to support this idea?
So far there hasn't been any direct observation of antimatter structures.
Yeah, okay.
On a cosmic scale, we haven't detected any anti-galaxies or anti-stars,
Okay.
for example.
Mm-hmm.
But the absence of evidence isn't evidence of absence, as the saying goes.
That's true.
I mean, it's a vast universe out there, and we've only just begun to explore it.
It's mind-boggling to even try to imagine an anti-universe with anti-people,
I know, right?
going about their anti-lives completely unaware of our matter-filled universe.
Yeah.
But even if we never find these anti-universes, just the fact that antimatter exists
Right.
has some pretty profound implications, doesn't it?
Absolutely. I mean, the very existence of antimatter challenges us
Yeah.
to re-examine some of our most fundamental assumptions about the universe.
Like what?
Well, like, for example, the matter-antimatter asymmetry problem we keep coming back to.
Right.
The fact that our universe seems to be dominated by matter
Yeah.
suggests there's something fundamental that we're still missing
Right.
in our understanding of the laws of physics.
So is it possible that there's some, hidden asymmetry in the laws of physics themselves
It's possible.
that we just haven't discovered yet? Something that, tipped the scales in favor of matter over antimatter in the early universe?
That's certainly one of the leading theories.
Hmm.
It's possible that there are very subtle differences in the way matter and antimatter interact.
Okay.
Differences so small that we haven't been able to detect them yet.
Right.
But those tiny differences,
Yeah.
playing out over billions of years of cosmic evolution, could have led to the universe we observe today, a universe made mostly of matter.
It's almost as if the universe had a preference for matter over antimatter.
Yeah.
It's like flipping a coin and having it land on heads almost every single time.
Right.
Something must be influencing the outcome.
Exactly. And uncovering that something
Yeah.
is one of the biggest challenges in modern physics. Experiments at CERN and other research facilities around the world
Right.
are constantly pushing the boundaries of our knowledge,
Yeah.
searching for those elusive clues that could explain why the universe evolved the way it did.
Thinking about all of this, from the possibility of anti-universes to the mysteries of matter-antimatter asymmetry,
Right.
it really highlights how much we still don't know about the universe.
It is humbling, isn't it?
It is.
We've come a long way in our understanding of the cosmos.
Yeah.
But every new discovery seems to open up even more questions,
Right.
pushing us further down this rabbit hole of scientific inquiry.
And that's what makes it so exciting. I mean, this deep dive has been incredible.
It has.
We've gone from the basic definition of antimatter to its medical applications,
Right.
its potential to revolutionize our understanding of the universe,
Mm.
and even the possibility of entire anti-universes.
It's been a pleasure exploring these concepts with you today.
Likewise.
Antimatter is more than just a scientific curiosity.
Yeah.
It's a key that could unlock some of the most profound secrets of the cosmos.
So for all of you listening out there, the next time you hear about antimatter, just remember,
Yeah.
it's not just science fiction.
Absolutely.
It's a real phenomenon, and its study is leading us on a path of discovery with profound implications
Yeah.
for our understanding of the universe and our place within it.
Couldn't have said it better myself.
And who knows, maybe someday we'll even have those antimatter spaceships.
Until then,
Yeah.
keep looking up at the stars and never stop questioning
Yes.
the nature of reality.
The universe is full of wonders waiting to be uncovered.
It really is.
That's it for our deep dive into the fascinating world of antimatter.
Yes.
Thanks for joining us.